Today I'm going to be covering problem number 20 from the 2025 AMC-8. I thought this problem was really interesting because when I was solving it in the actual test, I used a method that I thought was really beautiful, but there's also another method which is more straightforward and just overall a bit shorter. So today I'm going to be showing you both of those methods. So let's get to it. First, let's read through their problem together. Sarika, Dave, and Rajiv are sharing a large block of cheese. They take turns cutting off half of what remains and eating it. First, Sarika eats half of the cheese, then Dave eats half of the remaining half, then Rajiv eats half of what remained, then back to Sarika, and so on. They stop when the cheese is too small to see. About what fraction of the original block of cheese does Sarika eat in total? So the first method that I'm going to show you is called the infinite geometric sequence method. So before we get to the method, I'm going to show you guys what an infinite geometric sequence is. So an infinite geometric sequence is essentially a geometric sequence that never ends. But here, we're going to try and find the sum of this infinite geometric sequence. But you might be wondering, how do we find the sum of something that goes on forever? Won't the sum be infinite? Well, that's a good question, but mathematicians have found a formula to find the sum of this infinite geometric sequence, which I'm going to show you. But first, let's quickly cover what a normal geometric sequence is. So in a geometric sequence, let's take 1/3, 1 over 9, 1 over 27, and 1 over 81. In a geometric sequence, the common factor or the multiplier between two adjacent elements is always going to be the same. Okay, that can be more than one, less than one, negative, positive, anything. So here, so let's say this is the first element, the second element, the third element, and the fourth element. So the common factor between these is 1/3, again 1/3, and 1/3. Right, and this will keep on going, however long this geometric sequence is. But if it's infinite, this will never end. Okay, so essentially this will keep on multiplying by 1/3 forever. So now let's get back to the problem now that we've covered infinite geometric sequences. So let's write out the problem situation. We have Sarika, who eats 1/2, then Dave, who eats 1/4, then Rajiv, who eats 1/8, then back to Sarika with 1 over 16, then Dave with 1 over 32, then Rajiv with 1 over 64. So here we notice that this is clearly an infinite geometric sequence because the problem specifically states and so on, meaning they never end. I mean, they do stop when the cheese is too small to see, but technically you can still keep that as infinite because you don't know what too small to see is, right? So it is still an infinite geometric sequence. So now I'm going to show you the formula that I mentioned earlier to find the sum of an infinite geometric sequence, and here is what it is. Okay, so the formula is stated in general form as the starting value over 1 minus the common factor. So I want you to pause the video and think about what the common factor here is. Some of you might say 1/2 because you think that the set of elements that we're talking about is everybody. So you guys might think this is 1/2, right? But if we go back to the problem, it says about what fraction of the original block does Sarika eat in total? Okay, so the question basically just tells us to only look at the set of Sarika. So if we just look at Sarika, this will be 1 over 16 and 1 over, oh, sorry, this is a comma, 1 over 128 and so on. So if we look at the set, the difference or the common factor between these is going to be 1 over 8. Even here, it's going to be 1 over 8 and so on. So in our problem, S is equal to 1/2, which is a starting value, over 1 minus 1 over 8 is equal to 1/2 over 7/8 is equal to 4/7. So the amount of cheese, the amount of cheese that Sarika ate is 4/7 of the cheese rind. So if we go back, we can see that our answer is equal to A, 4/7. So this was the more straightforward method that basically you just know the formula, you apply it, and you make sure you don't make the mistake of thinking the common factor is 1/2 when it is actually 1/8. But now I'm going to try and show you a much cleaner, in my opinion, maybe more beautiful method. So here we go. So let's write out the problem again. S equals 1/2, B equals 1/4, Rajiv is equal to 1/8. Back here, 1/16, 1/32, 1/64, and so on. And I'm going to call these rounds, okay? Basically, when they take a turn, I'm going to refer to these as rounds. So this is round one, this is round two. So at the end of any round, we can try and compare the amount of cheese that these three ate in that round. So clearly, we can see that Dave ate 2 times Rajiv and Sarika ate 2 times Dev. So if we let Rajiv equal x, this would mean that Dev is equal to 2x. And this would mean that Sanika is equal to 4x. So now we can just add all of these up because we know these three are the only ones eating the cheese, right? So if we add all of them up, we'll get the entire cheese rind. So if we do that, we'll get x plus 2x plus 4x is equal to 1. One whole cheese rind. So then we get 7x is equal to 1. X is equal to 1/7. But people who didn't do this method would think, will look at the answer options and say, 1/7 isn't an answer. Remember, x is actually Rajiv's amount, and the question asked us for Sarika's amount. So if we do this, we will get s is equal to 4x equals to 4 times 1/7, which is equal to 4/7. And this is again our answer, option A. So I hope you guys enjoyed this video and learned a lot. If you guys have any questions, leave it in the comments. I'll try and get back to it. Also, if you guys have any problem suggestions that I should do, definitely drop that in the comments too. Don't forget to subscribe to get updated on future math videos. Thank you.